Hey guys, welcome back to the 𝗂𝗀𝗀𝗀𝗀 podcast. Me and Liv have actually barely spoken this week because she's been away for work. So how was your week, Liv? How did it go with work?
Oh my God, Taz. It was, do you know what, right, first of all, I'm going to start from the very start. To all the listeners, I went to Exeter this week for work and I went for like a meeting with collaborators. There was like people from all different universities who were all working on the same grant together. And we all went and like met. We were talking about what everyone's doing and all of that stuff. Firstly, before I left, I had an absolute breakdown to Taz about the fact that I had to go because just social anxiety and it was bad. So anyway, Taz convinced me that I should go and I was really close to just like calling sick because I just get really anxious about like going to like conferences and stuff. We spoke about this on the podcast before about
Yeah.
how I don't like conferences and it genuinely is because I just get bad social anxiety and it seems to be worse in work situations. But anyway,
Mm.
so I was like, no, I should go. Like, I want to be involved. And like, I actually did want to be there. It was just like the thought of going like made me feel physically sick. Anyway, Taz convinced me to go. I had a meeting Wednesday afternoon at 2 p.m. and it takes me 4.5 hours to drive to Exeter. So I was like, I'm going to leave at 7 p.m. I'm going to be in Exeter for 12. Got 2 hours to like figure out what I'm doing, find the room. Anyway, I get in my car at 7 a.m. and I'm like literally an hour into the drive and I've hit traffic already. I'll cut long story short, it took me 8 freaking hours to get to Exeter. I got to Exeter at 2 p.m., the time that the meeting was supposed to start. So I missed the first meeting. Not the end of the world, but it just took me so long to drive there. And then driving back, it also took me 7.5 hours. So I just
Oh
feel
my
a
God.
bit spaced out. And then when I got home at like 10 p.m. and I stupidly left my car door open all night. One of my neighbours knocked on my door this morning to be
Oh
like,
God.
I don't know if you know, but your car door's been open all night. I was like, that's just great. That just goes to show how tired I was when I walked in the door. But why did this 4.5 hour drive take me 8 hours? It was horrific. It was absolutely horrific.
Yeah, honestly, I feel like when you drive in the UK, especially, like a 2 hour drive can take 4 hours. And you're literally like, why? Why on earth did it take that long? So I completely feel you. It's even worse in Australia, honestly, because I have
Oh my God, I can
absolutely,
imagine.
I can't even fathom how big Australia is. And then
Mm.
I'm literally like, oh, I remember when me and Kieran went to Byron Bay, and I was like, oh, like it's only up the coast, like it shouldn't be that far. Tell me why it's a 10-hour drive just to go up
Oh
to
my
like the
God.
next main place in
That is
Australia
horrific.
from Sydney. Like that's literally the length of the UK. Do you know what I
That is
mean? Like I
literally
used to
insane.
drive to Scotland and it took me like 7 hours. This was 10 hours.
Yeah.
So it's kind of crazy how, yeah, like your perception of that kind of changes depending on where you are in the world or on the earth as
Mm.
well.
That is actually so true. It reminds me of like the first time I heard about like a space mission or like some kind of like NASA mission. And it was like, oh yeah, it's going to take like 6 months or whatever to get to this certain place. And I'm like,
I
what the actual
know.
hell? Like, imagine that. Like, you're going to be,
Imagine if you had to
or,
do that for a conference. See you in 6 months.
mate, no conference is worth that. Let me tell you that. But anyway, talking of space and our solar system, today we are going to be diving into the origins of our solar system. So let's get into it. Welcome to the 𝗂𝗀𝗀𝗀𝗀 podcast, hosted by Liv and Taz, exploring the world of science and tech unfiltered.
This season, we're diving into the origins and taking you on a thrilling journey through the breakthroughs and untold stories that shape today's biggest scientific fields.
And of course, every episode brings the same mix of fun, fresh perspectives, and gossip, aka LaboraTEA. From lab scandals to workplace drama, nothing is off limits.
This is 𝗂𝗀𝗀𝗀𝗀 Season 4, The Origins.
Imagine a time long before telescopes and satellites, a time when the only tools we had to understand the universe were our eyes and imagination. The night sky stretched above, glittering with countless stars. The Milky Way was like a luminous river cutting through the darkness. For ancient humans, this celestial display wasn't just beautiful, it was puzzling and powerful, and it inspired myths, it guided journeys, and it shaped their beliefs. But as we know today, those stars and planets hold secrets far beyond what early civilizations could have dreamed. And in this episode, we'll follow the story of how humans began to unravel those secrets, moving from ancient wonder to scientific discovery, one breakthrough at a time. And Taz, it all starts with a bit of mythology. We'll be exploring how those myths and early observations slowly turned into science.
I don't even know how our solar system came to be honest. So I'm very, very excited to hear about it in this episode.
So our story today begins with one of the earliest civilizations to document the heavens, the ancient Egyptians. So they didn't just see the sun as a glowing ball in the sky. To them, the sun was actually a god. And they believed Ra, the sun god, traveled across the sky each day in a heavenly boat and disappeared into the underworld at night, marking the cycles of day and night. And this wasn't just mythology, it was their explanation for a cycle that they couldn't otherwise understand, day and night. To the Egyptians, the stars also played an important role. So I mentioned that they thought of them as guiding spirits, and certain constellations had immense cultural and religious significance. For example, the appearance of Sirius in the pre-dawn sky signaled that the floods were coming. To them, the heavens were a clock, a calendar, and a cosmic drama all at once. But let's move east to Babylon in what's now known as Iraq. If the Egyptians were storytellers, the Babylonians were record keepers. So over 2,000 years ago, they started meticulously tracking the movements of the stars, planets, and even eclipses. But the Babylonians weren't just doing this for fun. They were laying the groundwork for understanding the universe. And they did this using a mathematical system called the sexagesimal system. And this system is basically all about how they used to count in 60s rather than 10s. And we spoke about all of this in episode 1 of this series, which was all about the origins of viruses. That was all relevant to how they were kind of responsible for the fact that there's 60 seconds in a minute and 60 minutes in an hour. So using this system, the Babylonians divided the sky into 360 degrees and further split that into 12 sections. And each section was actually assigned to a zodiac sign based on the constellations that were visible in that part of the sky. But here is where it gets really interesting. The Babylonians used this system not just to describe the sky, but also to study the movements of the planets. They carefully recorded how the planets moved through these sections, creating some of the first detailed planetary charts. Now, centuries later, the Greeks shifted the focus from just recording celestial patterns to asking deeper questions. So they were asking things like, why do the heavens move the way that they do? So Greek philosophers like Pythagoras and Aristotle, aka Joe Blogs, if you listened to last week's episode, they began developing models to explain the structure of the universe. And Aristotle proposed a geocentric model which placed the Earth at the center of the universe. So in this model, the sun, moon, planets, and stars were thought to orbit Earth in perfect circular paths. To account for their regular, predictable motion, Aristotle proposed that these celestial bodies were embedded in a series of transparent, interlocking spheres, which is kind of giving that Simpsons movie where Springfield was in that dome. Do you remember that? Did you ever watch that film?
I remember that, yeah.
It's kind of giving that. But this geocentric idea dominated for centuries, but not because it was accurate. So obviously we now know that not everything is centered around the Earth, but it was because it seemed to fit with what people could see and understand. But there was a major problem. So careful observations revealed that the planets didn't just move in simple, perfect circles around Earth. And every so often, a planet like Mars would appear to almost slow down, stop, and then move backward in the sky for a while before resuming its forward motion. And this puzzling phenomenon is what we call a retrograde motion. And I've always heard people talking about like retrograde, Mercury's in retrograde or whatever that means. But I've never heard of retrograde motion.
No, I didn't realize that that's like a actual scientific term.
Yeah, so let me break it down for you. So imagine that you're driving on a motorway and like passing a car in the next lane. So that car is obviously like moving forward. But if you're driving faster, it briefly looks like it's moving backwards as you pass it. And I also experience this a lot when I'm on the train. Like if there's a train next to you when you're on the train, it looks like the train is moving backward. And that is essentially what retrograde motion is. It's an illusion caused by Earth overtaking another planet in its orbit. Of course, ancient
Mm.
astronomers had no concept of planetary orbits yet, so they had to come up with a different explanation for this. And this is where Ptolemy enters the story. Ptolemy was a Greek astronomer working in the Roman Empire around 150 AD, and he was determined to solve the mystery of retrograde motion. So, in Ptolemy's system, each planet was thought to orbit Earth in a large circular path called a deferent. But to explain the apparent backward motion, he added small circular path called epicycles to the planet's orbits. So while a planet moved around Earth, it was also spinning along its own smaller circle at the same time. And his model was actually
Mm.
precise enough to predict the positions of planets fairly accurately, and so it became the standard for over 1,000 years. But as we'll see in this episode, these epicycles were just a workaround, and one that would eventually crumble as new ideas and more accurate observations emerged.
That is so interesting. They thought that Earth was the center of the universe.
Mm.
Like, I feel like that's a man's way of thinking.
Can't lie, I would have said that too. Like, I feel like it kind of makes sense. Like, I don't know. I'm just not that
Yeah,
clever. I'd just be like, cool, we're just here and there's like that thing in the sky. Like, I'm just not philosophical like that.
it's giving main character energy, you know, like, calm down. We're not the center of the universe. But, like, obviously, we know that we're not, and, like, everything doesn't revolve around the Earth. So, at what point did they find out that it was, in fact, the sun?
Mm-hmm. Yeah, good question. So along came a guy called Copernicus who dared to propose a radical new model, the heliocentric model, which is the idea that the sun, not Earth, was at the center of the
Mm-hmm.
universe. Now, this model faced heavy resistance, but it did inspire others like Tycho Brahe, who gathered precise data, and Johannes Kepler, who discovered that planets move in elliptical, not circular orbits. And finally, we've all heard of Galileo. I feel like there's a song about him. Like, I think I'm going
Galileo,
on way too. Yeah.
Galileo.
I think I'm going on way too many tangents on this episode. Anyway, I don't know why that song always makes
It's a
me
great
laugh. It just
song. It's
makes me
by
laugh.
Queen, isn't it?
Oh, anyway, Galileo's telescope revealed Jupiter's moons and the phases of Venus, which was direct evidence that not everything revolved around Earth. So
Mm.
I've just kind of gone through that quickly, but yeah, these were kind of like all the things that basically made it obvious that the heliocentric model was correct and that Earth was not the center of the
Mm.
universe. So, with this model now firmly established, the next question was obviously, why do planets orbit the sun? Now, the answer came from Isaac Newton. So, in the late 17th century, Newton unified physics with his theory of gravity. Legend has it that seeing an apple fall inspired him to connect the force pulling the apple to Earth with the force that also keeps planets in orbit. So, his laws of motion and universal gravitation explained how the sun's gravity governs planetary motion, which tied together centuries of observations into a single elegant framework. But understanding planetary motion wasn't enough. People wanted to know, where did the sun and planets come from in the first place? Well, in the 18th century, Immanuel Kant proposed the nebula hypothesis.
I'm really excited for this, but I have to say, ever since you said Galileo, I've just got the Queen song in my head, like repeating over and over and over again. So
Same.
hopefully I can pay attention still.
Literally same. I'm not gonna lie, like I was gonna do a whole bit on like Galileo, but I couldn't stop laughing when I was like doing the research for it. And I was like, you're gonna start laughing in the episode, Liv, if you start talking about Galileo too much. But here we are, talking too much about Galileo.
Yeah, sorry. It's
Anyway.
already happening.
Yeah. So, Immanuel Kant likely drew inspiration for his hypothesis from early astronomical studies of nebulae, which were gaining attention in the 18th century. Using telescopes, astronomers observed these diffuse cloud like objects in the sky and noted their tendency to cluster near young stars, suggesting that they were actually the sites of star formation. So, the dynamic structures and shapes of nebulae hinted at gravitational and rotational forces in action, inspiring the idea that stars and planets could potentially form from collapsing clouds of gas and dust. Now, Kant was also influenced by contemporary scientific ideas, particularly those of a Swedish scientist named Emanuel Swedenborg, who proposed that the solar system originated from a rotating cloud of gas and dust under the influence of gravity. So, building on these ideas, Kant incorporated philosophical reasoning to suggest how dispersed particles might condense into stars and planets. However, due to his kind of like limited knowledge of physics and mathematics, and obviously like hardware and telescopes at the time, Kant's model had significant flaws, including its failure to explain why planets orbit the sun in the same direction and within the same plane. Now, about 40 years after Kant's ideas, Pierre-Simon Laplace proposed a more refined explanation. So he suggested that the sun was actually already fully formed and surrounded by an enormous rotating atmosphere that stretched far beyond the orbits of the planets. Now, adding on to that, he thought that as the sun contracted, he theorized that its rotation would speed up due to the conservation of angular momentum. Now, angular momentum, you can kind of think of it as, for example, if we think about like a figure skater, as they were like skating along and then they went into a spin, and if they like draw their arms in as they're spinning, it speeds them up even more. It's like a really similar
like
concept
you
in
on
like
the
pole
pole.
dancing. Exactly.
Yeah.
Like as you bring your limbs in, you speed up. So like when we're stuck in like a vortex on the pole and we're spinning really quick, everyone always says like stick an arm out, stick a leg out, because it will slow you down. So that's basically the whole idea behind like the conservation of angular momentum.
Sorry, can I just say that was so women in STEM, like describing
Oh my God, wasn't it?
angular momentum by like what
Using
you
pole
do
dancing.
in pole dancing. I love it. Carry on.
I'm so here for that. That was incredible. I love that. Oh my God, that's actually my favorite moment from this podcast, because you're right. Anyway, so this increase in rotational speed created strong centrifugal forces, which he proposed actually ended up pushing material outward. So, like maybe just like some gas and some dust would just be like pushed out. And over time, these rings of gas and dust coalesced into planets. Laplace believed this process repeated multiple times, producing the concentric orbits of planets that we observe today. And he even suggested that planets could actually form their own rings during their creation, which eventually would form moons. So, Laplace's model, known as the Kant-Laplace nebula hypothesis, offered a compelling explanation for why the planets orbit the sun in the same direction and also within roughly the same plane. So, by combining Kant's earlier idea of dispersed material condensing into planets with his own understanding of celestial mechanics, Laplace presented a more complete and scientifically grounded theory. And so, this model dominated scientific thinking about the solar system's origins for nearly a century. So, now we're in the 20th century. So, by the early 20th century, the Kant-Laplace nebula hypothesis started to face increased scrutiny, and scientists started to begin pointing out its weaknesses, particularly in its inability to explain the angular momentum distribution in the solar system and the irregular orbits of some celestial bodies. And this led to a search for alternative theories. And one of the most notable was the catastrophic hypothesis proposed by American scientists Thomas Chamberlain and Forrest Ray, which was later refined by two British scientists named James Jeans and Harold Jeffreys. So the catastrophic hypothesis is basically what it sounds like, and it suggests that planets were formed as a result of a close encounter between the sun and another star. So according to this idea, when two stars passed near each other, and also like, am I dumb if I remind the listeners that the sun is a star? Because does everybody know that the sun is a star? I think they do, right?
Well, some people might not.
Some people might not. So if you don't know, that's fine. And now you know that the sun is a star. So, according to this idea, when two stars passed near each other, the gravitational forces would draw material out from one or both of the stars. And this material would then like float off and it would cool and condense into planets. While this theory addressed some of the issues that we had with the nebula hypothesis, it did also have a major drawback. And that is that such close encounters between stars are so extremely rare in the vastness of the Milky Way. And if true, this would imply that solar systems like ours are exceedingly uncommon, which seemed unlikely given the growing evidence of planetary systems around other stars and the fact that we know now there are like so many other like solar systems and galaxies like ours. So as the mid-20th century approached, new discoveries began to shift the scientific perspective, and researchers gained a deeper understanding of how stars form and the behavior of gases in and around stars. And they realized that hot gaseous material pulled from a star's atmosphere, as suggested by the catastrophic hypothesis, would actually simply just dissipate into space rather than end up condensing into planets. And this effectively just like ruled out the idea that close star encounters could explain the origins of the solar systems.
See, you had me there. I was ready to just accept that hypothesis because I was like, oh my God, that's so interesting. Like,
Mood.
stars like pull out, we're remnants, Earth is remnants of a star. I was like lapping it all up, and then you're like, actually, no, it's not
Nope.
that. So basically what you're saying is scientists scrap this idea that planets are leftovers from like stars essentially fighting in space.
Yeah, exactly. So early astronomers studying the vast interstellar medium, which is essentially just like huge clouds of gas and dust scattered across space, realized these weren't just empty voids. They were stellar nursery where stars actually form. With this discovery, it made sense that planets might form alongside stars from the same material. And this realization encouraged scientists to actually revisit the ideas of 𝘂 and Laplace, who had proposed the nebula hypothesis over 200 years ago. Their theory, if you remember, suggested that stars and planets formed from a rotating disk of gas and dust. But at the time, they lacked the tools to actually test these ideas. So modern astronomy, armed with like more advanced telescopes and data, has revolutionized our understanding. So by observing star-forming regions in immense interstellar clouds, like the Orion Nebula, scientists noticed consistent patterns. Collapsing clouds of gas and dust flattening into rotating disks, which we now know are the birthplace of stars and planets. And these observations, paired with chemical analysis of meteorites, moons, and planets within our solar system, have built a comprehensive and evidence-driven model for solar system formation. So we're now at this point where, and I kind of love this because like the 𝘂 and Laplace, like everyone loved it, and then people were like, no, that's incorrect, and now they've gone back to it. And like now, because obviously like NASA can do all of these really, really cool missions. There was a really cool mission called the 𝘂𝘂𝗀𝘂 mission by NASA. So if you're interested in reading more about like these specific ones, I definitely recommend reading about the 𝘂𝘂𝗀𝘂 mission. But yeah, basically started doing all these missions and like finding all of this data that actually supported 𝘂 and Laplace's theory. And can I also just say one more point, which is that 𝘂 came up with this theory in the 1700s. Like, I just think that's insane.
Mad. I was also going to say as well, like back then, how crazy would it have been when like the telescope was invented and you're just looking up into the sky instead of seeing just like pinpoint stars, like you were just looking at the sky, you're seeing like these clouds of like early solar systems and stuff, and you're like your mind would be blown. Like I just think it's crazy to think about stuff like that.
I really want to do like a series one day where we talk about like the intersection of tech and science, like the evolution of the telescope would be so interesting and how that's advanced science. I just think that would be such a cool series. I would just love to do that.
Yeah, for sure.
But I want to talk about a pivotal figure in shaping this modern perspective, who was an astrophysicist named Alistair G.W. Cameron. And his work in the mid-20th century was instrumental in refining the nebula hypothesis into a more detailed and scientifically robust model. So Cameron's contributions emphasized that solar systems form as natural byproducts of star formation, laying the groundwork for what we now call the solar nebula model. So, what does this model say? Well, it starts with a vast, cold interstellar cloud made up of gas, which was made up of mostly hydrogen and helium and tiny dust particles containing heavier elements forged in earlier generations of stars. Something comes along and triggers this cloud to collapse under its own gravity. And this could be like a random increase in density within the cloud, or maybe even an external event, for example, like the shock wave from a nearby supernova. Now, as the cloud collapses, it shrinks and it becomes denser, with gravity pulling the material inward towards a central point. But as the cloud collapses, it doesn't just fall straight inward, it begins to spin faster. Like we said earlier, much like a figure skater or a pole dancer pulling in their arms during a spin. And this happens, like we said, because of that fundamental principle called the conservation of angular momentum. So as the rotation speeds up, the collapsing cloud flattens into a disc-like shape, a structure that we now call the solar nebula. And most of the mass ends up concentrated in the center, where the density and pressure build up so much that nuclear fusion eventually ignites, which gives birth to a star. In our case, in our solar system, is the sun.
Oh my God, that's crazy. Like, I can't even begin to comprehend. Like, obviously, it gets so intense that nuclear fusion starts, and then that's where the sun arises. It's basically like saying the solar system started as a giant spinning pancake of gas and dust.
That's actually a pretty good visual. Like, I love that because that is literally like what it kind of looks like if you Google like a picture of it. So we're going to go with that. It's a spinning pancake of gas and dust. Love that. But yeah, the solar nebula was essentially a spinning disk of material, a bit like a spiral galaxy, but on a much smaller scale. The outer parts of the disk, away from the heat of the forming sun, were cooler, and this cooling is what allowed particles of gas and dust in the disk to begin sticking together. And these particles were microscopic at first, but over time they collided with more and more and stuck together, forming larger and larger clumps. And this is where the process of planet formation or accretion begins. So tiny grains of dust collide and stick together through electrostatic forces, eventually growing into pebble-sized objects. And as these objects grow larger, their gravity becomes strong enough to pour in more material, forming planetesimals, essentially the building blocks of planets. Closer to the sun, where temperatures were higher, only rocky materials could condense, which is why the inner planets like Earth and Mars are rocky, and then farther out in the colder regions of the disk, ice and gas could accumulate, leading to the formation of giant planets like Jupiter and Saturn.
That's actually crazy because that kind of reminds me of when you are making a snowman and then you get like a small snowball and then you put it in the snow and then you push it and it like makes a bigger and bigger
Oh my
boulder.
God, yeah.
But it's actually really interesting how you mentioned that the planets closer to the sun are like more rocky because that's like where the rocks could condense into a planet, and then the further away you get it's like less dense materials. That's like, I didn't even think about that, which is
Yeah.
I didn't even know the reason for that, which is kind of wild. So that's really
Me too.
interesting.
Well, this is why we're doing this podcast. Listen, we're trying to educate ourselves, we're trying to educate our listeners, everyone. But yeah,
Yeah,
it is
exactly.
all about location and temperature. So the inner planets, bathed in heat, could only gather material like silicates and metals, which, yes, explains why they're dense and rocky. And then the outer planets, in contrast, formed in the freezer section of the nebula, allowing them to collect ice and gas in abundance. For instance, Saturn's moon, 𝘃𝘃, mostly made of water ice, has a density of about 1 gram per cubic centimeter, whereas the moon, composed mainly of rock, has a much higher density of 3.3 grams per cubic centimeter. And so another point is that we've mentioned that within the solar nebula, there's like these particles of gas and dust, and they're all collided and beginning to stick together, which forms these large aggregates. But near the midplane of the disk, solid particles settle quickly due to gravity, which creates these regions of high density. And these regions actually accelerate the process of growth through collisions. So within just a few thousand years, some of these clumps reach sizes of 10 kilometers or more, which we just spoke about, which are known as planetesimals, the building blocks of planets. And as these planetesimals continued colliding and merging, some of them grew into planetary embryos, which were moon-sized or even Mars-sized bodies.
That's really interesting. So it's kind of like you could see the nebula as like a giant pinball machine where like these balls are of aggregates are all like pinging into each other and then like colliding and aggregating and getting bigger and bigger and bigger.
Yeah, exactly. You've got so many good analogies, Taz. Love that.
I know.
But yeah, the planets that we see today and the planet that we're on right now are survivors of this chaotic phase. For example, Mercury's high density and Venus's slow retrograde rotation are likely the result of colossal impacts. And this period of intense bombardment lasted tens of millions of years, reshaping the young solar system, while the formation of Earth and the Moon was mostly complete within 50 million years of the solar nebula's collapse. Leftover debris continued bombarding planetary surfaces for hundreds of millions of
Mm.
years. This late stage bombardment, known as the Late Heavy Bombardment, left behind craters that are still visible on many moons and planets today, so for example, like our
Mm.
moon. And one of the biggest mysteries for Kant and Laplace's original model was the angular momentum puzzle. Why do the planets, which contain only a fraction of the solar system's mass, retain most of their angular momentum, while the sun, which holds the vast majority of the system's mass, rotates relatively slowly? So, in other words,
Mm.
basically, the less dense planets, according to their theory, should spin a lot slower.
Mm.
The puzzle was actually eventually solved by studying the solar wind, a continuous stream of charged particles flowing outward from the sun. So, over time, the solar wind carries mass away from the sun, along with some of its angular momentum. And this gradual loss of momentum has slowed the sun's rotation over its 4.6 billion years of existence, allowing the planets to maintain their higher angular momentum.
So it's given like the sun is a pole dancer and she wants to slow down. So she's like sticking her limb out, which is basically the solar wind. Another analogy for you
Oh
there.
my God. Women in STEM. Women in STEM. I freaking love this. Oh, this is so good. But interestingly, this is not unique to our solar system. And observations of other sun like stars show that they too exhibit slower rotation compared to higher mass stars, suggesting that the
Mm.
solar wind plays a universal role in shaping angular momentum distribution during planetary formation.
Yeah, it's just kind of mad to think that the solar systems and other solar systems came from just this cloud of gas and dust.
Yeah, I agree. But like, I always almost feel a little bit unsatisfied with this episode because at the same time I'm like, yeah, but how did the cloud of gas and dust get there? Do you know what I mean? Like,
Yeah.
so maybe we need to do like an origins of the universe episode because like what are
Oh
the
my
theories as
gosh,
to
yeah.
how, because I think when we initially spoke about this episode, like when me and Taz were brainstorming this episode, we were like, oh, we should do like an episode on the origins of the universe. And then we was like, but that's kind of like boring of like the Big Bang Theory, and maybe it'd just be more interesting to do like specifically like our solar
Mm.
system. But I do just feel like, wow, now I really want to go ahead and read more about like just the origins of the universe in general. But yes, this wraps up the science for today's episode. That was all about the origins of the solar system. So for now, we are going to be moving on to a story from one of our listeners. So let's get into it.
I'll slip into your dreams tonight. So give me your I'll stick like glue inside your mind.
So today I've got a wild listener story and it starts with I got scammed into a job by a guy who went to jail for putting a bomb in his university. So to give context, before COVID hit, I had a job in a research lab, but because of the pandemic, it was actually cancelled. And I was a second year student at the time, so I was very broke. And I was frantically searching for a job and even went into seeking arrangements to find a sugar daddy. Slay, okay, which is a big scam. Oh, okay. But I met this guy, let's call him Gavin, love that. He owned a company and I asked if I could work there. He agreed and it made my day. My first red flag should have been that I was not asked for any references, CV, or even an ID. Anyways, I went into the office every day for a week until on that Friday, he said that his rent in the building had increased and he was to vacate the building and we could all then just work from home. That's good. After a couple months of working from home, my payslip never showed up. Then one girl I worked with got a message from someone from Australia who told us about him being a fraud and a scammer. Gavin, however, kept asking all of us not to believe this girl and kept telling us that she is a psycho. That is a red flag for me when boys say girls are psychos anyway. All of his colleagues were rightly concerned, so we did some research on him. We found that he actually went to jail for putting a bomb in his university. Oh my god. That is so... What the hell? Anyway, I'll carry on. That was our last straw. Rightly so.
Literally.
And I and all our colleagues decided to quit. We all tried to get our money from Gavin and we asked him to pay us, but he ignored us. We even reported to the tribunal and got absolutely nothing from it. So my excitement of working during COVID and earning some money actually resulted in about £200 lost, not including my time. And my dignity, self-esteem and confidence were utterly destroyed. I stopped posting on social media. I'm still to this day terrified that somehow I will bump into him. Wow, sorry, a bit dark, but it was so traumatizing. I've learned from this a lot. I think I just need to hear you laugh off my naiveness and my stupidity for me to move forwards. I'm currently working in STEM and I absolutely love what I'm doing. I'm now happy and no stupid like Gavin could mess with me again. Jesus, that is
Bloody hell.
wild.
We have never met a nice Gavin on this podcast. Straight up. That is a lot, but can I start by saying that this is reminding me of the story that we had in season 3, I want to say, about the girl who went on the like internship abroad and then the guy like stole all of that. Oh, that's literally reminding me of that. Like, this is the same situation. We need to put these listeners in contact so they can just like rant about it together. But what the hell? I feel like there is so much to this story. The bomb, the fact that she hasn't been paid. Do you know what I want to know? What was the job? That's what I want to know, because it's like we go from speaking about like sugar daddies and that being a scam, but then we're going into a job. Like, what is the job? Do you know what I mean? Because she's working from home,
I kind of feel like she insinuated that she met Gavin on seeking arrangements, but I'm not too sure.
Is that a red flag in itself? Maybe not. I don't know.
Probably a red flag.
Not necessarily. Can we go to the bomb in the university and the fact that he got arrested? Like, do we know what he was arrested for? Did they say or not?
A bomb hoax.
That's what he was actually arrested for, like the bomb hoax.
Yeah, so obviously he was jailed for this, and the listener actually sent us a bit more information about it. And it turns out that when he was a teenager, basically he created a bomb hoax and he created like mass hysteria at a university because he'd faked the presence of a bomb being in the university, and as a result of that he got jailed for like 16 months.
Nah, because this has just made me even more intrigued as to like what the job was and like how he's got this office and like what is the situation, because like you literally went to jail for like, bomb hoax. So then like, what business are you now? Like, obviously I'm not saying that like, you know, people who, but do you know what I mean? I'm just so curious as to what the business is. Like, I just want to know what it could be.
Well, obviously it was just like probably just a fake business.
No, because why would it be a fake? Why would it be a fake business? Because she was obviously doing something, like she was doing some type of work, right?
Yeah.
Oh, I'm so intrigued as to what it could be.
Also, I love our listener who was just like, I was a broke student, so I went on seeking arrangements, didn't work out. Then I did this other thing. Turns out like the guy who runs it is a fraud and a scam artist, and he also went to jail for a bomb hoax. And it's just like, girl,
She's been
what
through
world
it.
are you living in?
She has been through it, but also I'm gonna say, like, this girl's a hustler. Do you know what I mean? Like, she's out here trying to get her bag.
Yeah.
Because, like, I think every single student 100% has had that moment where they really sit down and they're like, I
Should I
need a
be on
sugar daddy.
OnlyFans?
Should I be on OnlyFans? Should I sell my feet? And, like, legitimately, like,
Yeah,
we've all been
100%.
there. So
100%.
I pat you on the back if you've actually gone and done it. Like, I think you're a hustler. Get your bag.
Yeah, me too. I agree.
I mean, and I also want to know, like, how did the sugar daddy thing end up being a scam? Like, that I need to know the details of as well, to be fair.
Maybe nothing came from it, I guess. But yeah, I think it's so funny how we've all kind of been there. Like, I know you do pole, but even when I was at uni, I was like, maybe I could just be a stripper in Brighton and get loads of money whilst I'm here because I watched
Mate,
some
imagine
documentary.
how often I think about that, because,
Yes, you must.
like, you've seen me dance. Like, I reckon I could do it.
100%. I'd literally be like this. Men on the ground will be like flying money at you. I'd be there on your first night, like, go girl.
Oh, I mean, no, all jokes aside, like, that's like a whole nother discussion for another day. But yeah, we've all been there. So I love that she's a get her bag kind of girl. But I mean, what should she do? There's nothing she could really do. Like she said, she just wants us to laugh it off. But I just feel bad for her.
Yeah, I feel bad for her, but it seems like she's kind of slaying now. Like she said that she's in STEM, she's happy about life, and she's learned a lot from it. So I'm happy for her.
Me
And
too. It's
obviously, there's a lot of takeaways that we can take from it, right? Like take
sugar daddy's a
background
scam.
check.
Oh, we took two different things away from that. You're more sensible, so you do the takeaways.
So the takeaways are: when you're getting a new job, you need to check the employer. Glassdoor is a really good website for like workplace culture. People leave reviews on the workplace on Glassdoor, so that's really good. And yeah, contract. I'm sorry, but as women in STEM, or just women in general, we need to be looking in that contract. We need to be disputing the pay. We need to be saying, hey, my credentials are a lot higher than what is in this. Always push for more money. Like, I'm sorry, not enough women do it. When I got my job in Australia, I didn't end up getting pay rise, full transparency, but I was just like, right, I think I'm just going to try and prove that I am in the next pay bracket. And the HR lady who was dealing with my contract was like, I actually love this from you. I always get men asking for more money, and it is so rare for me to get a woman asking for more money. And I was just like, look,
know your worth, girl.
If you don't ask, you don't get. That's what I say.
I'm so here for that, to be honest. And the other takeaway that I took was sugar daddies are a scam. So let's remember that. But I definitely want some more details from this listener. I want to know why sugar daddies are a scam. So if you could send in another LaboraTEA, that would be great, please. And thank you.
Okay, I think that wraps up everything for this week's episode. And next week we are delving into the origins of sex from like a human perspective, but also biologically as well. So that's going to be a really fun episode. But before we go, I just want to say, if you are listening, we do now have video episodes on YouTube as well. If you prefer to watch along instead of just listening, then head over to YouTube at @sooo_cultured_podcast and be sure to subscribe. But for now, that is the end of the episode, and we shall see you guys next week.
See you next week.